Hi, Advanced Algebra 2. Welcome to part 2 of our Concept 22 notes, inverse functions. We're going to start back with example 3. As I go through these examples quickly, remember that you can always pause the video so that you can catch up with the note taking. So now we're going to find the inverse of a cubic function. So first of all, think about a cubic function. Is it 1-to-1? Well, you know that you can graph it, and we graphed one similar in the part 1 notes. And so this is 1-to-1. It will pass the horizontal line test. So now let's write it in equation form, and then remember, interchange your x's and y's and solve for your new y. So subtract 1, divide by 2, and now you're going to take the cube root of both sides, so everything, the numerator and the denominator. So there's our inverse function. Let's write it with that notation. We have a cube root function, and we know that cube roots are also functions. So is our original 1-to-1? Yes, it is, and so that ensures us that our inverse is a function. It will pass the vertical line test. And inverses, remember, just undo the math of each other. Example 4. So we're just finding inverses of all different kinds of functions. Now we're looking at this radical function. So it's a square root function. What's the domain and range of this? Well, look, it's a square root, so it will have a limited domain so that we would get real number outputs. So we need to stop the domain what's underneath the square root is 0. So that means all our numbers that are greater than or equal to +3 will work for the domain. Now the range is just going to be where it usually would for a square root function, all the y values that are greater than or equal to 0. So remember that the domain and range of inverse functions are switched or interchanged. So now let's find the inverse of this square root function. So write it in equation form, interchange your x's and y's, and then solve. So divide by 2, and then square both sides. So we'll get y minus 3 equals x squared over 4 because we need to square both the numerator and the denominator. Now let's simply add 3 to both sides. So already knew that squaring something will undo a square root. So it makes sense that the inverse function is a quadratic. And now let's write its domain and range. So to figure out that for the domain of our inverse function, we're going to look at the range of the original, which is greater than or equal to 0. So that means our domain are all the x's that are greater than or equal to 0. Now for our range of our inverse function, we look at the domain of the original, which is greater than or equal to 3. So that's all the y values that will be greater than or equal to 3. Let's try another one. So now we have f of x equals negative x squared with a limited domain. So we're just focusing on the y values that are less than or equal to 0. So over to the right, I'm going to do just a quick little sketch of this graph. So it would be the x values that are less than, and it will be reflected. So it's this part of our parabola. Now let's interchange our x's and y's, divide by -1, and then take the square root. So y equals the square root of negative x. Let's go back to the original and just specify what the range is. So that's all the y values that are less than or equal to 0, and you can see that happening on the graph over here. So for our domain and range of our inverse, we are simply going to look at the range and domain of our original. They're both less than or equal to 0. So that means for a function, inverse function, they both need to be less than or equal to 0. That's just a property of inverses. The domain and range are just switched or interchanged from the domain and range of the original. Now there is a mathematical way, besides looking at the graphs, to tell if functions are inverses. So if they're inverses, they undo each other. So plugging in the output of one function should give you the input of the other. So in general function terms, f of g of x will equal x, and then likewise g of f of x will equal x. So if we have two functions like in example 5, f of x equals 3x minus 1 and g of x equals x plus 1 over 3, we can determine whether they are functions by composing them like in above. So first let's start with f of g of x and see if it equals x. So f of, we go grab g of x, which is x plus 1 over 3, and we plug it into f of x. So that's 3 times x plus 1 over 3 minus 1. So the 3's will divide out, and then we'll have x plus 1 minus 1. So yes, we are back to our original output. So now let's check g of f of x and see if that does indeed equal x. So we grab f of x, which is just 3x minus 1, and we plug it into our g of x function. So up top, we're going to, our 1's will subtract out. We'll get 3x over 3, which will simplify to simply x. So the fact that when I compose f of g of x and it equals x, and then I also go the other way, g of f of x, and that equals x, that means that these functions are indeed inverse functions and they undo each other. Now look at example 6. So let's look at a formula. We can find the inverse of a formula. It's a little different when we have an equation that's in x and y form. So we're going to find the inverse of this function or formula that represents the surface area of a sphere. So s equals 4 pi r squared. R is the radius of the sphere. And then we're going to use that inverse formula and find the radius of a sphere that has a surface area of 100 pi. So for a real life situation, a formula that has variables with meaning that are not x and y, there's something else, we do not interchange or switch the variables because meaning is tied to those. We just simply solve for the other variable. So write down your formula, s equals 4 pi r squared. To find the inverse, we're simply going to solve now for the variable that it is not solved for, which is r. So we just undo the math. We're going to divide both sides by 4 pi. We can do that all at once. R squared will equal s over 4 pi, and then we need to undo the squaring by taking the square root of both sides. So r will equal the square root of s over 4 pi. I'm not going to worry about rationalizing the denominator with this formula. So now we're going to answer the second part of the question, finding the radius by plugging in 100 pi for surface area. You won't even need a calculator for this because your pi's will divide out. 100 divided by 4 is 25, and the square root of 25 is 5, and it's only positive 5 because we're talking about a measurement. So the radius will be 5 feet. Now, here's one last fun example of our application where inverse functions can be used. So they can be used to encode and decode messages. So, and you can create a secret message. So I created a secret message that you see on the screen, and I did it using numbers that correspond to letters in the alphabet. So the message was created with the equation y equals 2x plus 5. Now, for you to decode my message, first of all, you need to find the inverse of that function of y equals 2x plus 5. Then you're going to plug in the numbers of my message below, 15, 7, 19, 29, 15, 43, into that inverse equation one at a time, and then look at the chart to see what letter in the alphabet the number corresponds to. So first, on your notes page, and I don't even know if this is a problem on your notes, but somewhere, either on space, let's find the inverse. So let's back up a little bit. Okay, so there's our equation, y equals, and you're going to switch your x's and y's, so it'll be x equals 2y plus 5, and now solve for y, so subtract your 5 and divide by 2. There, so there's the equation that we will use to decode my message. So start with 15, plug it into your inverse equation. 15 minus 5 is 10. 10 divided by 2 is 5. Look at your chart. The letter that corresponds to 5 is E. Now look at 7. 7 minus 5 is 2. 2 divided by 2 is 1. The letter that corresponds with the number 1 is A. And I bet you can tell what my message is going to be, but let's keep going. So 19, put it into your inverse function. You should get 7. You find the letter that corresponds with that, G. Now 29, put it in. You should get 12, and that corresponds with L. 15, we've done that already. That's going to be correspond with the letter E. And then finally, 43 minus 5 is 38. 38 divided by 2 is 19. 19 corresponds to the letter S. There. So my secret message is Eagles. Go Eagles. All right. This concludes our notes for Concept 22, Part 2, Inverse Functions and their applications.